So now the next thing we're going to talk about is address some of the tools related questions in here. And for this I'm going to go over and cover these topics in here. So these are the different topics that we're going to cover. These are the commonly asked questions like where can I find the tool related preferences. So we briefly touched upon this topic in here. So if you go back into your CAM application and right on the machining browser, you will notice that there is preferences, and right under preferences you'll find cutting tool preferences. So right in the cutting tool preferences, the tool related preferences is it's automatically set by default to load the last loaded tool library on startup. Now since I have not chosen a tool library to load, as you can see here, the default tool library field is empty in here, so which means I have not specified a library to be loaded at startup, so it's not going to load any library. So the next time you load a library, it'll automatically map that folder path where the tool library and the file name it's set to, and it's automatically going to load that. Now there's one for English tools and one for metric tools, so you can have a tool library for English and metric tools, and you can have them loaded automatically. So if your workspace is set to inches, it'll load the inch tool library that you've chosen, and if your workspace is set to millimeters, it'll load the millimeter or the metric tool library that you've chosen. So this is where you'll be able to locate the tool related preferences. A lot of times I get questions asked, how can I print the list of my tools that are being used? So if you have a library of tools loaded in here, I'm going to grab another tool library, and you'll notice that I have a total of about 14 tools, and I could click on list tools, and this is going to list all the tools that are loaded from the library, so which means all the tools that are in your tools tab. Now selecting print will allow you to print this. You can print it, send it to your printer, or if you have a PDF converter, you can save a print and then you can choose a PDF converter as your program, so you can print it out as a PDF and have that information handy. Now I also have been asked several times questions like how can we output the list of tools in our posted output file in a posted G code. So you might be wondering, is there a way to print or list all the tools in the posted output file? Yes, there is an easy way to do that. In order to do that, you would have to set up a environment variable on your in your system environment variable preferences. I'm going to go over that. Now before I do that, I want to just add a couple of machining operations in here, and we'll show you how that information can be output. So I'm going to go ahead and quickly identify some features and program a couple of machining operations in here. So first thing I'm going to do is a facing operation. I'll pick a tool for that. I'll pick the face mill, generate the tool path, and then I'm going to pick the pockets in here, program a pocketing operation with a 1/2 inch end mill. So I have two operations created in here. Now as I go ahead and post-process these operations, I'll choose one of the post-processors in here from the list, and I pick post. You'll now notice that the tool information, the tool numbers are being output, but if you'd like to output the tool list in here, you would need to actually set up an environment variable, and I'm going to show you how to do that so the tool list can be output right at the start of your posted code. So you would want to go into your control panel, and you can go in there, edit environment variables or edit system environment variables. And as you go into your control panel and the environment variables under system properties tab, under the tab called advanced, you're going to find environment variables. And under system variables, you would want to add a new variable in here, and the variable name is going to be vcam underscore write tool list, all in uppercase, and then you can just set the variable value to be as 1. So I'm going to set that, and you'll now notice that the variable that you created is defined under system variables. So again, the variable name is vcam underscore write tool list, and you want to add this new variable in here. And I'm going to go ahead and minimize this posted output file save this file. I'm going to close out of the application and go back and reopen it. And let me go back and load the part back. So we still have the same two operations in here. I'm going to right-click and post-process the setup. And I'm going to go back and repost it. And the posted code should output the tool name here. So let me take a quick look here. I may have had a typo in here. So as you specify the environment variable and specify a value for it, this would be outputting the tool list in the posted output file. So you need to specify the environment variable, and you would need to specify a variable value for it. And then once you post it, the tool list will get output in here. So I'll look into it to check why I was missing the tool list from being output, but I can verify that and get back to you on it. Now, if you also want to output this, this is one of the ways to do it. Now, sometimes we get questions asked, why are the feed rates in the posted code too high or too low? So one of the things you would want to check is in your post processor. So if the program feed rate is not what you're seeing in the posted code, you'd want to go into your feed rate tab or feed rate section in the post processor and make sure your high and the low values are defined correctly in the post processor. So if these values that you're seeing here for the high value, or if the values that you're seeing for the low value needs to be adjusted, you would need to want to make sure that you want to go back and update this in here. So for example, if the program feed rate in your machining operation is set to 350, but the high value in the post is set to 300, the posted output would cap it to the high value that you define in the post processor. The same thing works for low value. If you had a low value set to 5, but your program feed rate was 2 inches per minute, then the posted output file will set it to the low value that's defined in your post processor, which would be the value of 5 inches per minute or whatever value that you put in here. So you would want to make sure that these values are being set in the post processor, the high and the low values, depending on what it is, what your machine tool is capable of handling.
Uday, I just want to interject here a little bit about this environment variable that you set for listing the tools. I believe we'll have to regenerate the toolpath again to list it. And then the other number 2, the note I would like to make to our users is, why do we have a complicated scheme of having an environment variable? Actually, in our 2018 release, this environment variable will be moved into a UI setting in a preferences is being done. And so the reason behind us using environment variables is sometimes when we get user requests and we don't want to make it available to all users, we use this sort of scheme. And once it's tested and proven useful, then we actually move it to the mainstream product. So that is why we have this environment variable set for now in the 2017 release. In the 2018 release, we will actually be moving it to a user interface. Thanks, Uday.
Thank you, Joe. So I'm just trying to go back in here and make sure I get the toolpath regenerated so we can go back and output the tool list in here. So I'm just going to make sure that I have if there was any typo in the, yeah, I did have a typo in the environment variable name. I apologize for that. So I should have mentioned that I should have the variable name, I had an error on it. So I'm going to go back and fix that in here and show you how we can output the tool list. So I'm going to go back and close the application in here, and I'll go back into the environment variable. And in the environment variable settings, the variable name should be vcam post. I missed out the word post as part of the first set of characters in here. So it should be vcam post underscore write tool list. I apologize, instead of vcam underscore write tool list. So I'm making a correction in here. So once I have made those, once I've added them into the environment variable in here, if I go back into the application and post process the toolpath, right-click and post. I'm going to output it in here. You will now notice that the tool list is being output at the start of your output file. So the variable name is vcam post underscore write tool list. I had it initially set incorrectly, so that's the reason why you weren't seeing in the posted output file. Now you can see that all the tools that are used in your operation are now being output in here. Okay, so we'll move on to the next frequently asked question topic is what about feed rates for tapping operations? Now for tapping operations, the feed rates can be output in different formats. So typically for a tapping tool, you would have your feed rate is computed as pitch times RPM for most controllers. So you would enter the thread pitch as part of your tool definition, and your RPM is set in the feeds and speeds dialog in here. So I'm going to use an RPM of 500 and save this as a new tool. Now, as you program a tapping operation, whole machining and tapping, and if you pick a feature and generate a tapping operation in here, depending on the post processor that you select in here. So for example, if I pick a different post processor from the list and I post process the machining operation, you will notice that the feed rate for tapping is computed based on pitch times RPM. So the macro in the post processor is set to a macro called cycle underscore IPR. If you notice the feed rate macro here in the post, it's using cycle IPR. This uses pitch times RPM for the tapping operation. Now certain controllers expect 1 over threads per inch to be output as the feed rate for tapping. So you can replace this cycle IPR with a macro called cycle underscore TPI or cycle underscore 1 over TPI. So all of these macros can be found right in your variable list in here. As you right click on the in the post generator where you can enter in your variables, if you right click, you'll see that there's a variable for cycle underscore 1 over TPI. So when I insert this macro in here, cycle underscore 1 over TPI, as opposed to using cycle IPR, if I save the post and I go back and repost it, in this particular step, the feed rate is going to be 1 over 50 thousandths, which will end up being feed rate of 20, which is basically what the variable is going to compute and output the value. So you can output the tapping feed rates could be cycle underscore TPI or cycle underscore 1 over TPI, or you could even output, it can compute the pitch times RPM to establish that. Now if you go into the help section, the online help section in here for tapping, you will notice that if you go to tapping feed rates, all of this information is explained right in here. So that's about tapping feed rates. Now, how could you optimize your machining time estimate? So as you take a look at the machining operations that you programmed in here, if you go to right-click and choose information, it gives you an estimated time based on the parameters that you put in, like your cut feed rate, your spindle RPM, your step overs, your depth per cut. All of these parameters are used to establishing your machining operations info. It also takes into account your plunge, approach, engage, cut, retract, and departure feed rates. So you could go back and edit these parameters to optimize your machining feed rates based on your depth per cut, your step overs. All of these parameters are factored in when the machining time estimates are computed. So you can go back and optimize those, and then it'll establish the machining time estimates based on the parameters that you put in here. So for example, if I change the step over on the facing operation in here, if I change it from 25 to 40%, you will now notice that this affects your machining time estimate. So if I go back into information, you'll see that the facing operation now is little over 2 minutes or under 2.5 minutes. So you can optimize these by entering in the appropriate parameters for your step overs, your depth per cut, and also your feeds and speeds.
Uday, I want to jump in here. One of the things about the machining time computation is actually pretty simple. All we do internally is take the length of your tool path, take the entire length of your tool motions, and multiply it by the velocity of the tool, which in this case is the feed rate of the tool. So there's only two things that affect the machining time. One is the length of your tool path motions, and then number two, the feed rates you've assigned. So in order for you to optimize your feed rates for the machining time, these are the only two variables you're playing with. In order to reduce, if you want to speed up your machining time, you have to reduce the number of motions and or increase the feed rate. So that's as simple as that. So you got to keep an eye on your non-cutting feed rates. Those are the areas where you can optimize it most, because most of the time the cutting feed rates you're pretty much based on the material and the tool. And then, of course, as Uday pointed out, step overs and cut depths will affect the length of the overall motions. So these are the only two ways you can do it. So hope that makes sense.
Thank you, Joe. So we have a few more FAQs in here, and I'll try to go over them. We may be running a little bit over time, but I hope all of our attendees are okay with it. So, so how can I add comments in the tool? So we did talk about briefly here, in the early part of the webinar. So you can specify the comments to be output in here. So for example, I can, if I want to output the tool name as a comment, I can enter it right in here. If I want to output like an optional M code or a G code, I can add a prefix like $, as a prefix sign, and then specify the code that needs to be inserted. So when I make those changes and save those comments by saving edits to tool, and I'm going to go back and repost this out in here. So if I go back and post the entire setup, and you will notice that as we go from the first tool to the next tool in here, those comments are being output. As you can tell, the first one was just a comment. We just entered in the tool name. For the second line of the comment, I inserted a $sign and I put in M00. So you can see that this is actually output as a it's a non-comment, which is basically a code, an M code that can be interpreted by the controller and not just as ignored as a comment. Now, if you'd also like to have the line numbers to be output with the comment, you can go into your post processor in here, and you have the option to output the sequence numbers for comments as well. So now when you go back and repost this code, you will see that the comments also will have a line number to it. So there is the comment and the next line, which is basically the comment be added to be as part of an M code and with a line number to it. So that's how you can insert comments. Now the comments can be inserted in the tool properties, or you can also insert comments under each machining operation. You can right click and go to properties. You can also specify comments. It can be a comment, could be a single line or a multi-line comment, and you can specify it here. And as you can see, the tool tips that pops up, or when you hover the cursor on each of these boxes, it says if you add a $, as a prefix, this would skip the comment, start, and end character. So there's a lot of help built into the product here, as you can tell. So this will help you in adding comments to each operation, or you can have the comments set for each tool in the program. Now the next thing we would want to cover is how can we add a tool change point that can be output in the posted code. So if you have a manual tool change that is involved, or if you want to move the tool to a specific tool change point so that it makes it easier for the operator to swap off the tools, you could go into your machine setup dialog in here, and you can specify a tool change point right under the general parameters. You can specify an XYZ value in here. So in this particular example, I'm going to put in a Z value of 3 inches. I'll leave the X and Y as 0. So once this parameter is specified in here, you would want to go into your post processor, and you would need to insert those variables for a tool change. So before a tool change is performed, I could insert the variable for the tool change. I could say I want to move the tool change to an X value, Y value, and a Z value. So as you right-click, you have all of these variables in the post processor, and we have a variable for tool change point X, Y, and the Z. and you can select the variable and insert it right in here. So you have the tool change point X. I'm just going to make a copy of this and specify one for Y coordinates and one for Z coordinate. If you want to do the Z first and X and Y, so you just basically split that up into two lines. You can basically have this in two separate lines in here. The first line you could do a tool change point Z, so you want to retract the tool up into Z first, and then the next line you could do a tool change point X and tool change point Y. So that's how simple it is to insert the tool change point macros into your post, and the values are specified under the machine setup dialog in here. So if you put in a value for X, Y, and Z, those values will get output. If you leave them at 0, it's going to output 0 for tool change point. So now I'm going to go back and post it again, and you'll now notice that in the posted code, it outputs a G0, Z3, which is the Z of 3 inches I put in, and then the X and Y is 0. So that's how easily you can insert a tool change point into your program. The next thing I'm going to cover is how I could enable cutter compensation in the program. So cutter compensation makes sense in 2-axis or 2.5-axis operations like facing, pocketing, profiling, chamfer, and this can be set in the operation. So you want to first go into your machining operations. In this particular case, I'm going to give you an example of a profile operation. I'll select the face edge on this model for a profile, specify a tool for it, and in the cutting parameters, you have the option to specify your compensation. So we're going to set the compensation to auto on, or you could pick control on, where the tool paths are still automatically compensated by the tool geometry that you specify. However, the compensation is what you're compensating is more like for a tool wear at the machine or the controller. So you would want to also make sure that the cut direction is always set to climb or conventional in order to output a cutter compensation. Selecting mixed will not output the cutter compensation. You would then want to make sure that you specify your cut start side, which side you want to cut. In the cut levels, you can specify the depth in here. You can make sure you specify an entry and exit. So you want to make sure in order to output a cutter compensation, you either use a linear or you could use a radial. Certain machines prefer linear over radial. You can specify these parameters in your entry and exit tab for cutter compensation.
Uday, I just wanted to mention that the first motion always has to be a linear motion for the cutter compensation to be turned on. That's why we have the approach motion there that's got a length, a tangent approach motion, which will always be a linear motion. So yeah, controllers cannot apply cutter compensation on an arc, so we have to have a linear motion.
Thank you, Joe. So once we have this specified, you'd want to pick generate. So the toolpath is generated, and you also want to make sure that your entry and exit is being applied in here. So if you're profiling on an inside corner and you're not seeing the entry and exit, even though you specified an entry and exit and you're not seeing the entry and exit being applied in the toolpath, then you won't be seeing the cutter compensation being applied. So make sure that your toolpath preview also shows the entry and exit. So once you have this specified, the key things here is to make sure your cut direction is set to climb or conventional. You have your cutter compensation set to either auto on or control on. You have an entry and exit specified. And when you generate the toolpath, make sure the entry and exit are appearing on the toolpath preview. And also you got to make sure that the post is set up to output the cutter compensation. So if you go into your post processor, you have a section for cutter compensation, and this is where you can define your macros for cutter compensation. Typically, when you turn on a compensation, for compensation left, you would use a G41, and then you need to have an XY motion. The same thing applies for a compensation right, G42 with an XY motion. And for compensation off, you could just output a G40, or some controllers may expect an XY motion for that as well. You can put that in the post processor. And on some controllers, you also need to output a D value, which could be your Cuttercom register value or your tool number. You can specify those in the post. And once you have those set, when you post process your machining operation in here, you will notice that it turns on the cutter compensation on the first linear move, and it turns it off at the exit motion. So this is how we can apply and cut a compensation, and the compensation, the value that you're trying to compensate for tool wear is entered in your controller's tool table. The tool paths, however, are still automatically compensated by the tool geometry that you define for programming the tool path. So what you're compensating here is for a tool wear at the controller. Now this can be done in two axes, facing, pocketing, profiling, chamfer. The operations that allow cutter compensations, you'll see the compensation option under the global parameters in the cut parameters tab. So with this, I've covered most of the FAQ topics that we had for today for our webinar. I would like to go ahead and hand this back to my colleague Krish.
Unmuted.
Thank you, Uday. I know that we are running a little over, but I wanted to make sure that we also mention that a lot of this information is available to you in addition to the webinars that we do. We also have information available to you specifically on this topic in your Visual Serve login. And this is for the AMS customers where you can log into Visual Serve and you have all of these resources available. And then we also have a blog article that was published. While Uday is navigating to just show you where you can find this information, I just wanted to make sure that we mentioned it. So you have access to this specific topic both through this blog that Uday is showing right now and through your Visual Serve login for the AMS customers. And our goal with these seminars is to provide you with as much information as possible so that you can be independent, you can be efficient in what you're doing, and these are all of the resources that are available. And as you may recall, this is our second seminar on the topic of tools and feeds and speeds and basically this area. So I just wanted to quickly point that out. I realize we're running a little bit late. With that, if there's any questions, please go ahead and we'll be happy to answer.